Hi, in this video, we will discuss about Cohen Sutherland line clipping algorithm. What is clipping? Clipping is a procedure of identifying the part of the image which lies inside the window boundary and removing the part of the image which lies outside the window boundary. So let us consider this particular image. We will set a window against this particular image. So window can be a region against which an object is clipped. So let us consider this as our window. So the window is normally defined by its diagonal coordinates xw min, yw min, xw max, yw max. So now the clipping is identifying the path of the image which lies inside the boundary and removing the path of the image which lies outside the window boundary. If we apply clipping, then we should get only the image which is inside the window boundary and the other part should be removed like this. So we have to achieve this with our clipping. We have different types of clipping: point clipping, line clipping, polygon clipping or area clipping, curve clipping and text clipping. So we discuss point clipping, line clipping, polygon clipping or area clipping in my videos. Point clipping. What is point clipping? Given a point P of x, y, we have to decide whether the point is inside the window boundary or outside the window boundary. We can achieve this by using an inequality. That is, if x lies between xw min and xw max, then we say, and also the y lies between yw min and yw max, then we say the point P of x, y is inside the window boundary. So any point P of x, y, we can just check this condition and decide whether it is inside the boundary or outside the window boundary. This we call it as point clipping. Line clipping. Given a line with two endpoints x1, y1 and x2, y2, we have to clip the line segment against the window boundary given by the window xw min, yw min and xw max, yw max. So to clip this, let us consider this particular window. Now, if the particular point line is completely inside, that is both the endpoints are inside, then we say the line is completely inside. Consider this particular example. Here, both the endpoints are outside the window boundary, so we can say the line is completely outside. If you consider this line, it is intersecting with the top boundary, and this line 4 is intersecting with more than two window boundaries. So line 3 and line 4 requires some clipping. So we need to apply some clipping algorithm. Cohen Sutherland have proposed a line clipping algorithm. So line clipping algorithm consists of 4 steps. Step 1, we have to decide which line segments require clipping. Step 2, identify the intersecting boundary. Step 3, calculate the point of intersection. Step 4, save the endpoints and repeat the steps if necessary. These are the 4 steps of Cohen Sutherland line clipping algorithm. Let us see how it works. In step 1, to decide which line segments require clipping, we assign a 4-bit binary code word for each endpoint. So if we consider this as our window, we assign the bit 1 to 1 if it is on the left side of the boundary, and bit 2 is assigned to 1 if it is on the right side of the boundary. Bit 3 is assigned to 1 if the particular endpoint is on the bottom of the boundary. Bit 4 is assigned if it is on the top of the window boundary. Let us discuss the step 1 of our Cohen Sutherland line clipping algorithm. For this, we assign a 4-bit binary code word for each endpoint. This is our window. If the endpoint is on the left of the window boundary, then the bit 1 is assigned to 1. If the endpoint is on the right of the window boundary, then we assign the second point to be 1. Second bit to be 1. If it is on the bottom of the boundary, then third bit is set to 1. If it is on the top of the boundary, then the fourth bit is set to 1. If the point is completely inside, then all the 4 bits are 0, 0, 0, 0. So we can also assign the diagonal values also based on this condition. Now consider this particular line segment. Both the code words are endpoints are inside. So the code words are 0, 0, 0, 0. Consider other example. Here the one of the line endpoint is inside, so code word is 0, 0, 0, 0, and this particular line endpoint, the code word is 1, 0, 0, 0. Consider one more example. Here the code word for this endpoint is 0, 0, 0, 1, and this endpoint is 0, 1, 0, 0. Like this we can assign a code word for each and every endpoint. Once we assign a code word, we have to decide whether we need clipping or not. If the particular line is completely inside, then it does not require any clipping. So to identify that, we are going for this condition. Case 1. If both the code words are 0, 0, 0, 0, then the line is completely inside the window boundary. Case 2. This line is completely outside. So identify this. We are going for performing an bitwise AND operation of both the code words. So bitwise AND operation results in 0, 0, 1, 0. That is, if we are getting a non-zero as a result, we say the point line segment is completely outside. In case 3, the line may intersect with the window boundary, that is, it needs clipping. So when you perform the bitwise AND operation, if you get 0, 0, 0, 0, but the code words are not 0, 0, 0, 0, then we say that the particular line intersect with the window boundary and it needs clipping. So we go for the next step. We have to identify the intersecting window boundary. So to identify that, we examine the code words. So when we examine the code word 0001, it means it is having 1 in the first position, means we say that it is intersecting with the left boundary. Second code word you check 0100, we have 1 in third position. So we say that it is intersecting with the bottom boundary. Like this, we can identify the intersecting boundary. Once we identify the intersection boundary, we have to calculate the point of intersection. So we can calculate the point of intersection by using simple equation. Let us consider this particular line. It is intersecting with the left boundary. So the x value of the intersection point is always xw min, and only the y value you have to calculate, that is y is equal to y plus xw min minus x into m. The same way, if a particular line segment intersects with the right boundary, the x value is always same, that is xw max, and we have to calculate y as y is equal to y plus xw max minus x. The same way, if a particular line segment intersects with the bottom boundary, the y value is yw min, and we have to calculate x value like this. The same, if it is intersecting with the top boundary, then y will be always yw max. You have to calculate x, like x is equal to x plus yw max minus y divided by m. So now we got the point of intersection. We can clip the line. So once we clip the line, once again the line may intersect with more than one window boundary. In this particular case, the line is intersecting once again with the bottom boundary. So we can examine those resultant bits and we can identify it is bit 3. So we can calculate the point of intersection once again with the bottom boundary. So what we say the endpoints and repeat the steps if necessary if the particular line segment intersects with more than one window boundary. This is your Cohen Sutherland line clipping algorithm. Let me summarize. Step 1. Assign a 4-bit code word for both the endpoints. If both the code words are 0000, it means the line is completely inside. So we save the line segment and return. Else, perform the bitwise AND operation of code words. If the result is non-zero, it means the line is completely outside. So we can reject the line segment and return. Else we have to go to step 2. It means it needs clipping. In step 2, we identify the intersecting boundary by examining the code words one by one. Step 3, we calculate the point of intersection of the line segments. And step 4, we save the endpoints and go to step 1 once again. If the particular line segment intersects with more than one window boundary, then we repeat step 1 once again. This is our Cohen Sutherland line clipping algorithm. For more details, you can read Computer Graphics by Hernan Becker. Have a nice day.